Yeah, I've definitely had those moments before. I remember one time keenly, I did something and I went to refresh a page and I got an error, and you just have that sinking feeling where you swallow your heart and realize what just happened. You watch your phone, all 20 lines on your phone light up. You turn around and close the door and stick your head between your hands and try not to hyperventilate.
Welcome, Sterling Jackson, today on the Cloud Data Summit podcast. Sterling, can you tell me a little bit about yourself and your background?
Yeah, my name is Sterling. Obviously, I'm lead data engineer at Lirio. I've been here just over a year now. I've been working with software engineering and data for about 15 years. I have an entrepreneur's spirit, which is probably why I'm happiest at startups. And I've tried my hand at several endeavors, including an all-in-one ERP, hyper-local social network, and a mixed panel alternative. When I'm not wrangling data or wrenching on one of my side projects, I enjoy video games, craft beer, tennis, and reading. I find that I'm great at starting new projects, not so good at sales and marketing.
As is typical of data scientists and data engineers, right?
Mm.
No, so that's awesome. So right now you're at Lirio. Tell me a little bit about what Lirio does and kind of how you help Lirio as a data engineer.
Yeah, so Lirio is a data-driven organization that uses behavioral science, machine learning, and lots of data to deliver hyper-personalized messaging to facilitate behavior change at scale. We're headquartered in Knoxville, Tennessee, and we have a Nashville location where our sales and our behavioral science teams are located. Kind of what that means, what we do is that we engage with our customers to deliver specific programs like improved adherence with a diabetes treatment program or increasing compliance with recommended mammography guidelines. So for me, something that makes working at Lirio incredibly satisfying is that the programs we've selected have meaningful positive impact to people's lives. For example, our mammography compliance program helps detect cancer earlier when interventions are significantly more effective. And what we do is we take the behavioral science, we take the machine learning, and we take all of the data we have about somebody to figure out what that thing is, what that message, what that nudge is that is most effective for that person at that time to do the thing.
And so this is actually something that I personally have a fair amount of experience with. In my prior life, we were doing, I worked a lot in pharmacy and pharmacy benefits management, and we were working with health plans. And this is kind of the early days of HIPAA. We were working with health plans and figuring out how to do exactly this, how to do case management for diabetes. And so a lot of the really expensive chronic conditions that are expensive in aggregate, right? Mm-hmm. So, treating an individual person for maintenance is really not all that expensive. But if you have 20% of your population is diabetic, and you have a lot of people that end up in the hospital and things because they're not adhering to their medications, that becomes very, very, very expensive. And so that's something that we actually dealt with for a long time. So as far as like where the rubber meets the road, where does it, like what exactly do you do? Are you doing like proactive interventions and things like that? Is that kind of what the technology does?
So what it does is we'll work with a health system that will say, hey, here's our population of 100,000 that is non-compliant. We want to work with you to execute this program over 6 months or 12 months or whatever to push them toward compliance, right? So gotcha. If the recommendation is a mammogram every 12 months and they're 13 months or 16 months or 24 months, we want to push them to get back in compliance and do that every year so that we can detect it earlier on, like you said, when it's a lot easier to manage in terms of cost and in terms of invasiveness.
So then one side of the company is kind of the creation of the programs, right? Of these compliance programs that we're going to do, and then you're on the analysis side where you're saying, okay, did the people do what we wanted them to do?
Yeah, exactly. So I bring in data from our clients, process the data, hand that off to our machine learning team, our data science team, our software engineering team. Our data scientists put together some of their models, and their outputs also go to our software engineering team, who kind of build everything do the magic, put the emails or SMS, whatever. We're doing emails right now. We're adding SMS soon as a
Very
touch point.
cool.
So they put those together, push those all out, and then my team consumes the responses and creates a feedback loop there.
And so you're trying to find kind of like those ideal mechanisms and times to engage with the customers, right? So if it is a mammogram, you need to figure out, when can I get in touch with this individual person in this geography that meets this demographic profile or whatever, that's going to get a response from them, right? And ultimately get them to do the thing that we want them to do.
Yeah, not just the time, but the content. So that's where the machine learning comes in, is we have hundreds of different pieces of content in different categories that are designed to resonate with different people, different archetypes. So somebody who has kids might respond better to a message about their kids than somebody who doesn't.
Interesting. That's actually really fascinating, and we're not going to have time to dive into that on this time, but I'd love to follow up and maybe get some more insight into kind of how you do that, because obviously human psychology is a really big part of influencing change. And this kind of goes when you're talking earlier about data engineers and data scientists aren't great at selling, but that's kind of intertwined with a lot of what we do, because it brings in behavioral psychology, especially whenever we're touching people, and we need to know what influences that behavior. So to me that's really, really fascinating as far as how that's actually executed.
Yeah.
So you talked a little bit about, so you have multiple teams, you have data engineers, you have data scientists. Who else do you have on your, I'm going to use a very broad term and say data analytics team, as far as anybody that's involved in analyzing, visualizing, processing data? Like, what does that organization look like?
Sure. So our data team has changed a lot in the last year. We have several data scientists, several machine learning engineers, and a data analyst who does most of the dashboard and reporting work with Periscope. We'll probably be adding another data analyst before too much longer. Our data engineering team is also bucketed under that same team, our data science or artificial intelligence team, to use the hot marketing slogan. At the moment, our data engineering team is an army of one, but I'm in the process of hiring a second data engineer, and hopefully a third within 6 months. On that note, hiring technical people, especially out of somewhere like Knoxville, is all sorts of interesting. We benefit from being near to Nashville, which is only a couple of hours away. But hey, if any good data engineers want to come work in Knoxville, hit me up.
Absolutely. And then so kind of whenever you do that, and this kind of tails into the next question, and it's really kind of about segregation of duties, right? So whenever a new demand comes in from the business, whatever that is, how do you kind of divvy up the work? And and I know right now you're small because you're doing the data engineering, you've got one analyst, you've got a couple of data scientists, but like, how do you decide who does what?
It really depends on the type of request, and it kind of all melts together right now. Like you said, we're fairly small, so executives may come directly to team leads or our analyst, and then we kind of hash things all out. The majority of us are all in the same room right now, which is helpful. We have one remote machine learning engineer that's in our research team, so he's able to sort of do things off on his own, and that works. But the rest of us are in the same room, so it makes it easy to talk things through. Typically, new data sources are ingested and automated by the data engineering team, and then our data scientists and analysts start digging into it. A lot of the time, some sort of exploratory idea will be sparked from a random water cooler conversation or the development of a new program. So, for example, when we launch a diabetes program, we would need to create all sorts of supporting analytics and reporting around it.
I think that's great. I think that's exactly how it should work, because I see, too many organizations that kind of silo off their teams like that. And then the data engineers don't understand, they don't have an understanding of the strategic goals or the strategic objectives of what you're doing. It's, here's a data source I need, and here's a specification I need you to load this table. And, that's not really helpful to you as a, as a data engineering lead, to be able to look at, okay, what are we really going to do with this, right? So I think it goes a long way to have a tightly integrated team. And, you can even do that whenever you're larger, because I mean, frankly, even some of the largest companies in the world that have data scientists, they don't have more than a few dozen, so it's not like it's impossible to integrate, teams that are that size. So, but there's just so many of them that are just, kind of operate in silos. So I think that's very refreshing to know, even though you are small, that you're able to pull that off. So, so what does your non-data application ecosystem look like, as far as like the things that you are ingesting? So we've got, do you deal with ERP data, OLTP, website, CRM, Internet of Things? What do you kind of have in that ecosystem that you guys are handling?
Sure. So outside of the data team, we use all kinds of things, including Kafka, Postgres, WordPress, Salesforce, Confluence, various IDEs, Azure DevOps, and so on. I'm sure there's a lot more there. We pull in some data from our marketing team through Google Analytics. We also pull in some podcast engagement data through them. And we have a few other
That's very interesting
internal data sources that we ingest.
And so is this, and now do you have a custom application that users are interacting with? How do you actually get user behavior data?
Right now, it's all through email. So we get the email engagement events back through our email service provider.
Gotcha.
So clicks, opens, all of those things on that. Other than that,
so you guys are kind of working as the ESP in the sense, right? You guys are processing all of the emails, collecting all of those events, and then ingesting that back into the data warehouse, right?
Yep, exactly. We also get data back from our customers. So that's kind of the key in closing that feedback loop. So with the emails, we can say they clicked it, they opened it. That's great, but that doesn't tell us the full story. Did they change their behavior, right? We need to see, okay, they booked an appointment 2 weeks after you sent the email. That matters.
And then so are you ingesting claims data? Or are you ingesting scheduling data? Like what are all the things that you're kind of getting on that side?
Yep, exactly. It really varies from client to client, but we get mainly we work with energy companies and health systems right now. So yeah, we get demographic data, we get scheduling data, we get appointments and procedures and things like that. From the energy side, we get energy usage, program participation, and so on.
Very interesting. And then so, and this may not really be applicable since you are a smaller company, but do you have, and if you do, what is it, your legacy tech stack? Do you have any legacy applications that are in your ecosystem?
Not really. It's mainly greenfield. When I joined, I was tasked with planning and building our data platform. There were a number of Postgres databases that were being used, but there wasn't really the notion of a comprehensive data platform at that point. So I've worked with the head of our data science team to build out everything in the past year, and I'm pretty happy with where we ended up.
So the short answer is that your legacy infrastructure is a bunch of independent Postgres databases, right?
Yeah, that weren't really being used in any consistent way. When I started, we struggled to load a large file somewhere that it could effectively be used for a hackathon project. Today, ingesting and consuming that file is absolutely trivial.
Yeah, absolutely. No, and I think that's pretty that's pretty typical for a lot of organizations that have never really had any data engineering expertise on staff. And then so the next thing that I was going to ask was going to be around your legacy stack, but you don't really have, if you don't really have a legacy technology stack, you don't really have anything there. So I'm gonna pass on that one. So as far as like the type of data that you work with, are you mainly working with structured data that's coming out of rows and columns that are being provided by the customer or wherever, or is a lot of it unstructured blobs of text, content of emails, social media posts, and things like that?
Well, we work with a pretty good blend of all the above. Our machine learning teams typically work more with unstructured data than our data science and data engineering teams. I'd say the majority of our data is still structured and comes in daily, weekly, or monthly batches. We also ingest a lot of JSON from internal and external
Mm.
sources. Most
and
of the data that
and
we
a lot of
ingest
this
from
a lot of the
our,
structured data is like we were talking about, like claims data and email opens and things like that, right? That are very event driven data from other applications.
yep, exactly.
And then as far as the unstructured things, are you actually, like, for example, going in there and looking at Facebook posts or something like that to try to digest the contents of those and figure out what people are saying?
Not currently. We've discussed doing that. Most of the unstructured work is done with the content that we generate. So some of our machine learning engineers build models so that we can take the engagement we have with a piece of content and kind of transfer that over to a similar new piece of content.
I see. So if you have an email that works or a podcast that works or something like that, you're going to try to disseminate the content of that piece of content, right? And then figure out how to replicate it.
Yep, exactly. And not even that piece of content as a whole, but the individual pieces. So the subject line versus the call to
Absolutely.
action versus a paragraph. We're very granular with how we track those as well as how we build the messages.
No, I think that's very fascinating. I think that's a great application for actually doing unstructured data analytics that a lot of people aren't really thinking about, right?
Right. Yeah,
So no, go ahead.
there's a lot of opportunity there, I think, in that as compared
Mhm.
to, sentiment analysis or something like that on social media content.
Absolutely, yeah. So, what led you down the cloud path? As far as why did you not choose to deploy a lot of these technologies on premise when you originally started doing your builds?
We already had some products and services developed using AWS, so it was logical that we'd continue down that path. And since we work with enterprise customers, there are a lot of wins in terms of scalability, reliability, and
Mhm.
security using AWS. As far as Snowflake goes, we weren't originally married to the idea of a managed data warehouse. It just seemed to be the best option during evaluation. At FICO, Fair Isaac, if you bought a house, you're familiar with a FICO score. I used Vertica on dedicated hardware, and it was a hassle a lot of the times to make sure it ran smoothly, and that probably influenced choosing a managed solution.
Yeah, well, and that's a very common issue, kind of no matter what the vendor is, right, or no matter what the technology is, in the sense that if you have it behind your four walls, you're completely responsible for making sure that it's performant, responsive, backups work, all of that stuff, right?
Yep, yep. It's generally just a lot quicker and easier to not manage hardware directly. It's a lot easier to scale EC2, just spin up 10 new instances as needed and then spin them down when your job is done versus having to manage a fleet of dedicated servers.
Very cool. And then and for the audience, so you are running Snowflake as a data warehouse platform right now. What platforms did you evaluate before you chose Snowflake?
Sure. We evaluated quite a few. Stepping back a little bit to our entire data platform for workflow orchestration, we looked at Jenkins, Airflow, and Luigi. There are quite a few new contenders like Prefect that have sprung up since we started down this path that are probably worth a look. And data engineering as a service also seems to be getting more sophisticated. We also briefly considered AWS Glue, which I think has had some nice features added in the last year that I haven't had a chance to take another look at. Snowflake has also announced similar features, like a built-in scheduler. It sounds great for
Mm.
simple ELT. But as far as data warehousing, we considered Snowflake, Redshift, and a Cloudera data warehouse. We also looked at Athena, Impala, Hive, and Postgres using Citus. Snowflake seemed to tick all of the boxes in terms of power, price, flexibility, polish, HIPAA compliance, and so on. So a year later, we're still learning things that we get for zero effort through Snowflake and are huge fans. We've recently gained access to their data exchange private beta, which is really promising if it comes to fruition and essentially eliminates the ETL process of moving data back and forth between third-party vendors and your system. We've also started setting up an automatic replication and failover site on the West Coast using a new service from Snowflake. So there's just a lot of wins.
Very cool. And then so you went through, you looked at all these vendors. How did you actually evaluate them, or how much effort did you really kind of spend? Did you do bake-offs? Did you do little POCs? Like, how did you actually go and say, okay, this is the one we're going to go with?
Yeah, I would say we got really lucky when choosing technologies for our data platform. I worked closely with our director of data science to establish our requirements and our nice to haves. So we created a list of our options and started to evaluate them against our requirements before running POCs, starting with the top contender. Being able to separate storage from compute and scale them independently, especially at the data warehouse, was really important to us, which Snowflake does very well. Yeah, at the time we didn't have a lot of data for testing, so I ended up creating a test file by concatenating the same file to itself repeatedly to get some number of rows that I can't even remember now.
I think we've all done that.
Yeah, but it worked.
And so whenever you did that, I mean, did you actually take and throw that workload at, several of the different platforms that you were after and say, how does it perform?
Sure. So we started with Snowflake because that was our top pick. And I think the biggest concern was we get all of these bells and whistles with Snowflake and it looks absolutely incredible. It's going to cost a lot. So we thought that was potentially going to be a no-go. We couldn't get good metrics from their sales team. It was really hard to get specific. You can process this number of records and gigabytes
Of
with
course.
the size of warehouse. So we took the $400 trial credit that they offer and ran through our tests with that. And we didn't get through more than maybe $150 worth of credits.
That's crazy.
Yeah, so we were happy at that point with the performance. We were happy with the cost. So we decided to just end the thing there. We didn't go any further with evaluating anybody else. And Airflow was kind of similar. It had all the capabilities we wanted, and we just didn't see a lot of need to move on beyond that.
Very cool. And then what about your other what about your data pipeline tools or your ETL tools that you have in the ecosystem? How did you did you go through that very same process before you decided on a platform?
Similar process. Yeah, we went through our notes, what we wanted, what we didn't want, what our options were, and Airflow looked like the best option there. Airflow using Python. We started with the Python operator. I'm not sure if you're familiar with Airflow, but they have their abstraction is a variety of operators. You might have a bash operator, a Postgres operator, a Python operator that does a specific type of work, and then you chain it together into a job and manage your dependencies. So it did everything that we wanted. Our approach evolved a couple of times. We started with the Python operator, just running Python scripts natively. Later, we moved to the Docker operator and eventually the Kubernetes operator. So today, all of our jobs run Docker images on Kubernetes there.
Very interesting. And then whenever you were actually going about selecting these platforms, did you go to a lot of the vendors with kind of your wish list and said, can you guys do this? And then, how did you how did a pick become a top pick? Did you throw it over at their sales team? They looked at that and go, yeah, they just gave you the runaround, or how did you narrow that down?
Most of the research we did independently, just because we didn't want our decision to be muddied by a salesperson saying, hey, yeah, we can definitely do that. So we kind of categorized them based on how we felt that they met our nice to haves and need to haves, and then went from there.
Very interesting. So with all of those things, you made all these decisions, you implemented these. What do you like about what you're currently running on? What's good about it? Why are you happy about your decisions?
I would say Snowflake is one of the best decisions I've contributed to. We're really happy with Snowflake and have every intention to continue using it as one of the pillars of our data platform. It's been one of the most reliable pillars. I'm also happy with Airflow and Kubernetes now that everything is running stable, but getting there was definitely a chore. I've also used AWS Lambda in the past, and I really like it, but we're not using it in a meaningful way this time around.
But on the data pipeline stuff, all of that is up in the air, right? As far as in the future, it doesn't sound like you're really married to your current data pipeline tools, right?
It's the way we approached it, it's fairly agnostic. So we're not using all of the Airflow specific capabilities that Airflow offers. We mainly use it for task dependencies, for orchestration, for scheduling and logging. All of the compute happens on Kubernetes, so we could replace Airflow relatively easily. And Kubernetes just runs Python applications that are bundled up in Docker. So we could replace the Kubernetes compute layer as well. I think we're happy with it right now, but we certainly could change it out if there was a big need.
And I'm curious as well throughout the whole thing. Whenever you decided on a data pipeline, is there a reason that you didn't choose a managed ETL vendor rather than going the custom route?
Yeah, there were a couple of reasons we didn't spend a lot of time exploring those. They seemed inflexible. We didn't want to get tied into their specific workflow, and we wanted to be able to support a variety of workflows. So both the data engineering and the data science workflow, I think we talked about that briefly maybe 6 months ago, why we chose not to use Pentaho. Yeah, a lot of it was flexibility. A lot of it was just control, being able to really tune different parts of the system and make it do exactly what we wanted and not be shoehorned into somebody else's design.
Gotcha. Makes sense. And then so for all of the tools that you have implemented, you would kind of mention what you do like. Is there anything that you don't like about your existing stack?
Getting Kubernetes and Kafka up and running and integrated with our data platform was painful. Both seem to be overly complicated black boxes with vague errors or no errors, which really contrasts pretty strongly against Docker or Snowflake or Python that are much more explicit and easy to work with. So I'd say we're happy with Kubernetes and Kafka today, but it would be nice if the process of integrating them was a lot smoother.
That's kind of a common common perception, not just of those, but out of a lot of the Apache tools. I mean, that's been a big complaint about a lot of the Hadoop ecosystem for a very long time, right? Yeah. Where they're all, every individual tool is a black box. How do we integrate X tool with Y tool? And it's really hard, and it's kind of something that everybody's been struggling with for the last decade, right?
Yep, we've seen the same thing with Airflow, which is also an Apache. there seems to be a trend there, yeah.
Yeah, it's like nothing wrong with Apache. It's just that there's a lot of the tools that seem to get deployed. Yeah, they don't have robust error messages. They don't have a lot of documentation about correct use and incorrect use and expected errors and things like that, right? So it ends up being a lot of trial and error as you do it. Exactly. And then, of course, no vendor to go to and say, hey, why doesn't this work, right?
Right, you're kind of on your own to sink or swim.
Absolutely. And then so with all of these tools that you have in here, so you've talked about Docker and Kubernetes and Snowflake and all of the infrastructure layer part. Mm-hmm. How do you scale all of these individual nodes and individual elements of your infrastructure to really leverage the power of the cloud?
Sure. So we built everything within AWS to scale. We use S3 and EFS for scalable storage. We use Kubernetes over EKS for scalable compute. So our implementation of Kubernetes will spin up additional nodes and spin them down as needed based on the number of jobs that are happening. Airflow runs our jobs on Kubernetes pods. So quite a few of our jobs are embarrassingly parallel and can be distributed across workers simply by partitioning by row number. Of course, Snowflake manages data warehouse scalability for us. We're still typically getting away with using their smallest virtual warehouse, which is awesome.
So as you're doing it, you're using Snowflake. You're just using built-in and scaling right for Snowflake, and then on your data pipeline side, you are leveraging you're leveraging auto scaling on Kubernetes and on Docker, right, to be able to automatically add nodes or add resources to those nodes as necessary to be able to handle by number of queued jobs, right?
Yeah, exactly. And then if we have a data set that needs to be chunked across multiple workers, I'm a big fan of the default partitioning algorithm that Kafka uses for evenly distributing records across workers. I think it's, you take a unique numeric value and then you do the modulus of the number of workers, and that tells it which worker to
Right.
distribute it to.
Yeah, when I believe that's how most MPP databases work as well, with the master node. Whenever it figures that out, that's something that we dealt with ages ago with Teradata, when that was kind of the only game in town with partitioning.
Yeah, it beats the hell out of trying to do it manually.
Yeah,
Chunk
it absolutely does. Yeah. And then so I'd say, especially since you've kind of got two sides, and I'm assuming, well, and I didn't really ask about it, with as far as the way that you're doing data transformations, are you doing a lot of ETL or more ELT when you can?
A little bit of both. Typically, we ingest the data in as raw a format as possible. We don't like to modify it a lot going into the data warehouse, because we stage it and then we load it into an archive table
Right.
and a production table. So by doing that, we kind of have an easy replay point before we've started to modify it, and we don't have to go back to the source data. Then after that, we'll build data products on top of that. We'll do aggregations, we'll do transformations, but our other teams, the machine learning teams and data science teams, will also pull it down and do some combination of ELT and ETL. So they'll pull things down, run it through a model, put the results of that back up in the warehouse as well.
So the way that you're doing a lot of it now is you're handling a lot of the external sources like JSON, XML, flat files, whatever you get, those go through ETL, and then after you stage it, it becomes ELT at that point until somebody needs to pull it down for some reason.
Yeah, I would say largely. Yep.
That makes sense. And so that means you've got a lot of custom SQL scripts, right? And a lot of stored procedures that are kind of sitting around to be able to do that. So how, and this kind of goes into the next question, is how do you manage code deployments? So whenever somebody goes to make a change to an ELT transformation, how do you do source control, version control, approvals, and all of that stuff?
Yep. So we do source control and version control through Azure DevOps, which has a Git repository built in. So we do pull requests and all of those fun things. All of our jobs are built as Docker images, and they are deployed to JFrog Artifactory. Our data engineering framework automatically grabs the latest image when it runs a job on Kubernetes. So people making changes are aware of the fact that if they make a breaking change, they need to, as soon as that gets deployed, they need to make any necessary updates to the system so that doesn't break next time it grabs that latest image. Assets like config files or SQL scripts are checked into a repository that are synced whenever a job is created on Kubernetes for sort of continuous deployment approach. So one thing that's been really key to what we do is we try to make things as generic and componentized as well. So yes, we often have a lot of custom SQL scripts, but we have a SQL runner component that you can feed an argument to that says, okay, I need to run all of the SQL scripts in this process or this subdirectory.
Gotcha. So then it'll just pick up whatever happens to be sitting in that DevOps folder, right? It'll just pick it up, execute it, and then that'll be done.
Yep.
And then so you're doing continuous deployment. Do you do like daily releases, weekly? How do you end up executing it?
Largely as it goes in, kind of a continuous integration.
So if you've got a change and somebody just changed a SQL script, they'll give it to you since you're the lead, and they'll say, can you promote this? You'll look at it and say, yep, looks good enough. Maybe do some cursory testing, and then it'll just promote it right then.
Right. We have a little bit of maturity in that process that we're moving toward, but yeah, that's generally accurate. We've recently added a separate dev and QA instance in Snowflake. So we're moving toward a little bit more of a regimented approach.
That was going to kind of be my next question, is how do you go about doing that testing? And so it sounds like right now, or historically, you've been doing some testing in production, right? Or maybe copies of tables or something?
Yeah, we use copies of tables in the production instance. So we have a separate namespace, but it's still within the same instance. So
right. So you might not be colliding with production data, but you are going to be stealing resources from your production nodes, right? As you do that.
Right. And you make damn sure that you're targeting the right table name.
which could be innocuous in doing it, or it could be disastrous depending on what you're doing.
Yes. Fortunately, Snowflake has a really cool time travel capacity that I've never seen anywhere else. That's really awesome if somebody does have an oops moment.
Yeah, I think we've kind of all had that before, and and I have seen a few occasions where the undrop command in Snowflake was actually used, and we're like, boy, we sure are glad that was there, because the alternative was you would have had to restore a backup or something like that in
Yep.
another platform, and that means that could be down for several days, depending on how long it takes to restore that backup and retrieve it, right? And and I've seen some pretty bad scenarios about that before, kind of on legacy platforms, where something like that happened. You did have to do it, and then everybody's trying to everybody's kind of trying to do it quickly before anybody notices, let's get this thing, don't tell anybody, let's get it back up and running before before the boss finds out, right?
Yeah, I've definitely had those moments before. I remember one time keenly, I did something and I went to refresh a page and I got an error, and you just have that sinking feeling where you swallow your heart and realize what just happened. You watch your phone, all 20 lines on your phone light up. You turn around and close the door and stick your head between your hands and try not to hyperventilate.
Yeah, I think unfortunately most of us have been there on at least one occasion, right?
Hopefully just once.
Unfortunately, what's that?
Hopefully just once.
Hopefully just once, exactly. No, that's but no, that absolutely makes it a ton easier whenever you do, yes, on the database layer, you have the ability to time travel and undrop and all of those things, but also just the idea of being able to do the continuous integration. So if you do break something with a new script that you just rolled out, it's pretty easy to roll back that script, right? And then just roll back to previous state. So and that's a big thing that a lot of legacy deployments on traditional database technology has been painful to do in a lot of cases, to say the least.
Yes.
So so that's very interesting on how you manage them. So what are some of the biggest wins that you would say that you got from your cloud stack?
Seems like I keep going back to Snowflake. It's kind of like it just keeps giving. It seems like we discover something new about Snowflake every week that leaves us more impressed. We mentioned the time travel. There's the automatic failover and replication that can replicate to a different zone in real time. They also have built-in replication that replicates to two other availability zones within the same region. HIPAA compliance out of the box. So we've had a lot of wins from Snowflake at a really fantastic price.
HIPAA compliance is pretty big, right? Because there's not that many cloud applications, I suppose, that are HIPAA certified, right?
Yes, and the process of compliance, of getting the company and the processes compliant, is very painful.
Very expensive. Yeah.
Yeah.
And then, so if you had to make the same choice, would you make the same choices again if you had to go back and you knew what you know now, go back a year and you were doing this all over again? Would you do anything differently?
I'd say for the most part, I'm very happy with our platform. I think I would take a closer look at some of the managed and serverless workflow orchestration options. I think Astronomer has a managed Airflow service. And I recently saw a data engineering as a service product that I can't think of the name right now, but it looked very, very polished. I'd want to look into those a little bit more, just because we spent so much time and energy developing the framework that we use on top of Airflow.
Absolutely.
I'd really like to see something that works the same way, that was a more turnkey implementation.
Absolutely. No, I think that makes a lot of sense. And then, so obviously you're a big Snowflake fan. What are some of your favorite data-oriented tools and technologies, whether we're talking about data pipeline, database, data visualization, analysis, you name it?
I'd say Python, Docker, and Snowflake are all pillars of our data platform that I'm very happy with. Really, Linux and Bash definitely deserve a mention. They're not fancy, but they sure get the job done. Docker and Snowflake often feel like black magic in terms of what they can do and how easy they make it to do those things. Is always appreciated. Kubernetes on AWS EKS is awesome, but that's only once you get it up and running. Getting there was definitely painful.
And so, what is the one piece of advice that you would give to others who are doing what you're doing, who are ultimately starting on this journey, be more competitive in their industry using data and analytics?
No pressure, right? Building a data and analytics platform is not a small undertaking, and key decisions can make an enormous difference as it grows. I think it really pays to think about building resilient, repeatable processes and platforms. For example, we could have built and managed our own data warehouse over Hive, but it almost definitely would have been more expensive and time consuming than using Snowflake. I'd probably have to have somebody full time just managing Hive and potentially a cloud engineer as well, dealing with the infrastructure. I'd say also when building your ETL jobs, think about repeatability. We see lots of examples of people building Airflow jobs by manually defining each task and operator within individual Airflow configuration files so that each person ends up building jobs differently with zero consistency. That's kind of an operations nightmare. God forbid you have to make global changes across hundreds of jobs on any regular basis. So what we do is we define jobs as config files that a job generator script reads and sends to a job factory so that all of our jobs are created in a uniform, predictable way. I think that's the right way to think about things in a data engineering endeavor, because little things add up and get big and out of control really fast.
They absolutely do. And then on that note, I mean, that's one of the things, that's one of the reasons why companies started using ETL tools in the first place way back in the day, right? Is that, if you go back into the 1980s, a lot of companies, they were using, using Unix to do scheduling. They were using PL SQL scripts on Oracle to download data and manipulate it in code. And, and they learned a lot of these things back then, right? And decided it was a bad idea. And then, ETL tools were born and said, okay, now we have visual editors that make it easy for everybody to design in a consistent way, and everybody can understand how it works and debug it. And it kind of seems like what a lot of people are doing now is kind of going back to that. We're going back 30 years and relearning a lot of those same lessons that we learned in the 1980s and the 1990s to be able to make environments supportable at scale, right?
Yep. Yeah, it's really interesting to look at the paradigm with that regard. It seems like there is definitely that. You have your Pentahos, you have your SSIS, Talend, but you also have there's an increasing trend to use the things like Airflow that use code as the code as a config, I guess is what they call it, which is really interesting, rather than using the visual UI. And it's a trade-off, right? You can get something up and running a lot faster, I think, on Pentaho, but you get a lot more flexibility when you use something like Airflow, although that can be a double-edged sword if you do it responsibly and manageably.
Absolutely, yeah, and that's one of the things that I've seen. A lot of companies really struggling to do some very, very basic tasks. Where they might have a whole team of data engineers doing something that you could easily do with one person or half a person, because they've just so deep into this ecosystem, they just kind of created a big mess for themselves. That they can't easily support. They can't do changes. They don't know how to do code reviews and a lot of these sorts of things, and it just really gets unsustainable kind of as they mature, right?
Yeah, I think you always want to look at it from a times 10. If this works for 5 jobs, is it going to work for 50 jobs? Is it going to work for 500 jobs? If it passes that test, it's probably a good strategy. But
I think that's great advice, and that's something that I think a lot of decision makers really need to look at, right, whenever they're deciding on their technology stack, is to give it a little bit of testing and say, do we like the way that this is going to scale, either from a supportability point of view or from a runtime point of view, or however we want to look at it. Are we going to survive on this 2 years from now, or a year from now, or 6 months from now? no matter whether it works right now, right?
Right. Yeah, you don't want to throw out 12 months of work because these things take some time. Expect to spend 12 to 24 months building out a data platform. You don't want to have to keep redoing that. You want to be iterating on it and refining it, not starting from the ground up.
Absolutely. And then kind of on that note, do you kind of have any closing thoughts, closing advice that you would kind of give to other data engineers, other companies that are thinking about going down this path? Floor is yours.
Yeah, I would say a closing thought that is near and dear to me is to always remember to be ethical and responsible with all of the data we handle. We typically deal with millions of people's data, and it seems like there's a new report of some breach because someone didn't put a password on a database or made a business decision to use consumer data in a less than ethical manner. I would just really like to see our industry move beyond that.
I agree 100%. And, and I think that is probably not going to get any easier going forward because the idea of sharing data is getting more pervasive. And I think just the more data that is out there and available, the more potential that you're going to have to abuse or misuse it, right? And it doesn't matter whether it's private data that you might, be sharing from your organization via a data sharing platform, or whether it's public data that was collected through a government or something like that that's available. Both of them are just as susceptible to misuse, right?
Exactly. Absolutely.
And I think we've seen a lot of those examples, not just recently, but it's been kind of going on almost forever, almost since the beginning of data collection, where, especially in, I would say almost kind of in journalistic circles where people are looking for, a story, right, or looking for something that is newsworthy, that they'll go dig some study out that would otherwise be some obscure thing and then publicize it. Even if the study's wrong, it didn't really matter, right? Because it was newsworthy at the time and it fit our narrative. So we picked it up, we ran with it, we promoted it. And then, if it's wrong, they'll probably never issue a retraction unless that's also a story, right?
It doesn't matter if it was wrong.
Doesn't matter.
You can't rewind that.
Exactly. So yeah, I think it's absolutely unfortunate, but I do think it's also kind of unavoidable because there are so many organizations out there that kind of have their own agendas as far as what we expect to get out of this, and whether it's if I want eyeballs on my website, or if I want TV time, or if I want somebody to go download my research report, it's very easy to create skewed data, right, that I can put out there, or some skewed analysis that I can put out there that that might be, maybe I did do it with the right intentions, but if we didn't kind of put enough due diligence behind it, then it's going to be, the conclusions are going to be wrong, or the way that we massage the data might be fundamentally incorrect. And but nobody cares. They're just going to run with it, right? They're just going to come to a conclusion and say, here's my conclusion, let's go publish it, and then that's kind of the end of it. So yeah. I think it's kind of it's kind of a shame, but I think that just the more data is out there, and kind of the more quote unquote citizen data scientists that are in the ecosystem kind of doing their own analysis, the more of that there's going to be.
Yep, absolutely. That's why I definitely want to call out, just remember ethics whenever we can.
Ethics. And I think that's a great message and a great takeaway, and a great way to wrap it up. So I thank you very much, Sterling. I think it was a great interview, and we'll definitely drop your info in the video so anybody can get in touch with you if they have any questions. And thank you everybody for Cloud Data Summit podcast.
Thanks, Eric.